So this is another example. I'm still in class C address. It's the second example. It's got 60 hosts now. The question here is, how do you create subnets from network address 192.168.10.0/24, so each will have a maximum of 60 host addresses for the following VLANs. So in this case I've got 4 user VLANs, so there are a bunch of desktops in each, basically, different groups, departments, and each has a VLAN assigned. And I want to assign 60 host IP addresses to assign to those different desktop, laptop, mobile devices. And keep in mind, most of them will be part of a DHCP server pool. So when I create these host IP address ranges, this will be used to assign them to DHCP server pools to assign within each of these subnets. And so part of that is understanding how to configure a DHCP server pool. You have to know what IP addresses and what the ranges are to do that. So I've got 4 VLANs, 60 host IP addresses per VLAN, and starting with this this address here. I'm going to layer 2 switch. I've got the 4 VLANs here, 9 through 12. So it's pretty straightforward. It's very typical of what you're going to get with a switch. So step 1, calculate the subnet mask required for 60 hosts per subnet. So I want to know what the subnet mask is. I need 60 hosts per subnet. So going through this again, let's go to the far right here. I need 60 subnets. 30 is not going to do it, so what's the next one? 62. That'll do it. So go over, there's a /26 mask. That's a dotted notation there, 192. So the /26 gives me 62, so that'll work. So there's 6 host bits required to give me those hosts, and that leaves 2 bits left for subnet bits, and that'll be 4 subnets. So subnet mask calculation, I'm going to a subnetting table. We know that with 60 hosts it's a /26 subnet mask required. So taking a look graphically here, there's a /26. That's called CIDR notation, but it's just telling me how many bits there are. So 8, 16, 24, and into the 4th octet with 2 bits, that's 20/26. So that's the length of the subnet mask. 6 bits are available for assigning to hosts, and 2 for subnets. So let's start with the host calculation. From the far right, this is the host. There's 6 of them, 6 bits available to assign to host addresses. So if I start counting 1, 2, 4, 8, 16, and 32, there are my 6 bits and the values associated with them, and they add up to 63. And then the number 0 is another address available for 64 possible addresses I can assign. And 64, and I have to subtract the network and broadcast address, so that gives me the 62 host addresses available. So step 2, calculate the number of bits available for subnets. So I'm going to now calculate, I know that from the table I'm going to go to /26, so I have 2 subnet bits, and that's 4 subnets available. 4 subnets means 4 VLANs, so that'll work well for that. So there's only 4 available. So in this case there's the 2 subnet bits, 2 leftmost bits bolded, and that'll give me 2 to the 2 equals 4 subnets. So you can assign 4 different subnets from this network address. So I'm going to start out with that 192.168.10.0 class C address. It's a classful address that I've started with /24, and I'm going to use VLSMs or classless subnetting to create 4 different subnets from that single network address. And each subnet is a network address with a maximum of 62 host interface addresses available. And some devices, keep in mind, require more than 1 host IP address. You have servers that can use NIC teaming, for example, and that'll use 2 IP addresses. In some cases you've got routers and layer 3 switches that use a lot of host interfaces. So it's just desktops that typically will use only a single IP address. So step 3, identify the subnet multiple to assign subnets. So we're going to go over and figure out, okay, what's our subnet multiple? Well, it's that first bit there as a part of my subnetting bits. position is 7, but it's the value is 64. So 64 is the multiple. And there's only 4, so there's the 0 subnet, 64, then double it to 128, and then 192. And you can just see on this binary table, I keep including it because just to show you the bit position and what the value is, and to know that really well. But it's easy enough. Like I said, it just keeps doubling as you go from right to left. Step 4, so I'm going to calculate the network address, broadcast address, and host range for each subnet. So I'm going to start with the 0 subnet, 10.0/26. That's my 0 subnet, and the number of hosts is 62 available, and 64 is the subnet multiple. So I know the multiple, I know the number of hosts I can assign each subnet, and that allows me to calculate all of the subnets. So I started out with 192.168.10.0/24. Now I'm going to use a /26 subnet mask. I just showed here again, I used 10 for the example, but I used 11. So I get 4 subnets. We already know that. So 4 subnets. I'm going to start with the 0 subnet and assign that to VLAN 9. So that's 192.168.10.0/26. So the first host address available, this is the range. Now the host range would be .1 through to .62. And that gives me the 62 host addresses. And that's what you'd use for the DHCP server pool. And 63 is the next one, and that would be the broadcast address. Then going on to 64 subnet, that's the next subnet. And then 65 through 126 is the next subnet range of host IP addresses. And then on to 127. And the 127 is the broadcast. User VLAN 11, I've signed 128 subnet there. And so there's, like I said, there's a 128 subnet, the 192. It just shows you the host address range. It's pretty straightforward. There's 4 subnets, and this is the VLANs that they're assigned to. Here's an example of how I'm going to assign them. So there's 0 is the VLAN 9, VLAN 10 is 64, and VLAN 11 is 128, and VLAN 12 is .192. They're all network addresses.